This video is over section 3.1, the definition of the derivative. And in this video, we're going to go through an example of a problem that's asking us to find the equation of a tangent line at a point of interest. So this is number 31 in your book. It gives us this equation, and it's interested in the point a equals 3. Alright, so they're asking for the equation of a tangent line. In order to write the equation of a line, we need two things. One, we need its slope, and two, we need a point on the line. So in this section, it's talking about derivatives, and if you remember, the derivative is the slope of a tangent line at a specific point. Just what we need. And this section gives us two limit definitions of a derivative. We're going to go ahead and use both definitions in this problem just so that we see how both of them work and get a little bit more comfortable with each one. Alright, so looking at our first definition, limit as h approaches 0. This first part tells me to plug in a plus h wherever I see a t in my original function. But remember, our a in this case is 3, so I'll plug in 3 plus h wherever I see a t. So that gives me 3 plus h minus 2 times 3 plus h squared. Okay, and now I minus whatever I get when I plug 3 into my function. Minus 3 minus 2 times 3 squared. And all that is just over h. Let's go ahead and simplify this a little bit more. Over here, I have 3 plus h minus 2 times, when I multiply this out, I get 3 plus h times 3 plus h because it's squared. And when I multiply that out, I need to FOIL it, and I get 9 plus 6h plus h squared. Minus, when I multiply all this out, on the inside, I get minus 15. Remember, it's minus a negative 15, so that'll become plus 15. And all that is still over h. Okay, let's simplify this a little bit more. Alright, I'm going to combine my like terms. So I have a 3 and a 15 there that I'm going to add. That gives me 18. 3 plus 15, that's 18, plus h minus, I'm going to distribute this minus 2 into each term in this quantity. So that leaves me with minus 18 minus 12h minus 2h squared. All of that over h. Okay, we're getting somewhere. I'm going to combine my like terms again. On the top, the 18s are going to end up canceling. I'm going to add my h to the minus 12h, and that'll give me minus 11h. So now I have minus 11h on the top, minus 2h squared, all that over h. Okay, remember, this is saying the limit as h approaches 0 of whatever I have left. If I were to try direct substitution at this point and plug in 0 wherever I saw an h, I'd end up getting 0 over 0. It's an indeterminate form, not a valid answer. We need to do more work. So let's try simplifying this a little bit. On the top, I see that I can take out an h, and that'll leave me with minus 11 minus 2h over h. Conveniently, these h's will cancel. And now I'm just left with the limit as h approaches 0 of what I have left over, minus 11 minus 2h. I plug 0 in for h, and I'm left with just minus 11. Okay, so using this limit definition of the derivative, I was able to determine that the derivative, or the slope of the tangent line at this point, a equals 3, is negative 11. Alright, that was just step 1. We're going to do step 1 again with the other limit definition. Alright, so this is the limit as x approaches a. Alright, so let's go through it. The first part says f of x, so that just means I'm going to plug x in wherever I see a t in my function. So I have the limit as x approaches a of x minus 2x squared minus whatever I get when I plug a into my function, or whenever I plug 3 into my function. If you remember, when we plugged 3 into our function over here, we got minus 15. I'm going to skip a step. All that over x minus a, or just x minus 3. Alright, let's go ahead and simplify some things. So I'm going to rearrange this so it's written with the leading term first. So I have minus 2x squared plus x minus a negative 15 gives me plus 15. All that over x minus 3. Okay. Oops, this should be as x approaches 3. Remember, my a is equal to 3. Alright, if I were to go ahead and plug 3 into my what I have left right now, I'd end up getting 0 over 0. Okay, indeterminate form means that we need to simplify it more. Let's go ahead and factor this quadratic on the top. Okay, first, before I do that, I'm going to take out this negative just so that it's easier to see. So now I have minus times 2x squared minus x minus 15, all that over x minus 3. All right, now let's factor this quadratic over here. So when you factor this out, you're going to end up getting 2x plus 5 and x minus 3 on the top. And on the bottom, you still have x minus 3. Just what we wanted to happen. One of our factors cancels. And now we're left with the limit as x approaches 3 of minus times 2x plus 5. Okay, let's plug 3 in, see what we get. When we plug 3 in for x, we get minus 2 times 3 plus 5. 2 times 3 is 6, plus 5 gives us 11. But we have the negative in front, so that just becomes minus 11, which is what we would expect because both of these limit definitions are finding the derivative at the specific point, and so we should get the same value. All right, good work, guys. So that means that our slope, as verified by both of these limit definitions, at the point a equals 3 is negative 11. All right, problem's only halfway done. So to find the equation of our tangent line, we said that we needed slope and we need a point on that line. We have our slope. To find our point, we're just going to plug 3 into our function because that's the only point we know. So when we plug 3 into our function, I'll do that over here, f of 3, we've already done this before, but we get 3 plus 2 times 3 squared, which becomes minus 15. Oh, sorry, this should be minus. Okay, so now we have the point 3 minus 15. All right, here's our point. There was our slope. Now we're just going to put these two things together and make the equation of our line. So there's a couple different equations of the lines that you can use. Probably the easiest one is y minus y1 is equal to m times x minus x1. Here you just plug in your x's, your y's, and your m, or your slope. So for your y's, you have y minus our y value, which is minus 15, equals m, which is our slope, so which equals negative 11 times x minus our x value, which was 3. And that's your final answer. Let me write it in another color so you can actually see it. You get y plus 15 is equal to minus 11 times x minus 3. And that's the equation of the tangent line at the point a equals 3.